In this video, we're going to walk through the word problems, numbers 71 through 80 of your chapter review. So it says for each word problem, define necessary variables, write an equation to represent the situation, and solve the equation. So remember when we're doing word problems, we always have 3 or 4 steps. We always need to define variables first, write the equation, solve the equation, and then finally we need to make sense of what our answer is. So, number 71. Yesterday you had 14 apples. This morning you gave some to your friends. Now you have 8 apples. So how many did you give away? So we're going to say A equals apples. Apples that you gave away. Because that's what the problem's asking you to find. How many did you give away? So when we solve for A is going to be the apples that you gave away. So our equation that we're going to write, it says we started with 14 apples and we gave some away, which means we're going to subtract A, so we're going to subtract some apples, and then when we were done, now you have 8 apples, so you got 8 left. So now we're going to solve this equation, 14 minus A equals 8, and we can do that by subtracting 14 from both sides first, and over here those will cancel. Make sure you keep that negative with the A, and both of those come down, and 8 minus 14 is negative 6. But now, since you have a negative A equals and a negative 6, we need to divide both sides by a negative 1. That way these negatives will cancel. And you'll see over here on the right side those will cancel as well. So you're going to have A equals 6. So what does this mean? This means you gave away 6 apples. Because your value of A was 6 apples that you gave away. So there's number 71. Number 72 says, the perimeter of a square is given by P equals 4S, where S is the length of one side. So if the perimeter of a square is 48 centimeters, we're going to find the length of each side. So in this case, we're actually given the equation already, P equals 4S. And so we have 2 variables. We have P for the perimeter and S for the side length. And the question says, if the perimeter of a square is 48 centimeters, so we're given the perimeter, so we can put this 48 in for the P, and we say 48 equals 4S. And now it says find the length of each side. So what we're looking for here is the S, and it's kind of already been defined for us because it says S is the length of one side. So we don't need to worry about our variable definition because it's already done for us in the problem. So now we're just looking for S. Well, it looks like S is being multiplied by 4, so if we divide both sides by 4, those 4's will cancel, and 48 divided by 4 will be 12. And then we can use our symmetric property of equality and flip those around and say S equals 12. So the side length equals 12, and what's our unit? Is centimeters in this case. So each side is going to be 12 centimeters in length. So there's number 72. Number 73 says, Gerald is paid time and a half for overtime on any hours he works over 40 hours in a week. So a normal work week is going to be 40 hours, so anything above and beyond the 40 hours is going to be called overtime. So if Gerald's normal pay is $12 per hour, and normal pay means that's what he gets for the first 40 hours that he does. So how many hours of overtime did he have last week if he made $588? So we know that he makes time and a half for anything over 40, but his normal is $12 an hour. So he made $588. So since it's saying how many hours of overtime did he have, we can assume he worked all 40 hours plus a little more. So it's going to be, let's see, H is going to be hours of overtime. And now we've defined our variable, so let's write our equation. So 40 hours times $12 an hour is how much he makes for his first normal 40 hours. But then after that, he's going to make how much? Well, it says time and a half for overtime. Time and a half means you take this $12, you take half of it and add half of it back to it. So 12, half of 12 is 6, so 6 added to this 12 is 18. So make $18 per hour for how many hours? Well, we're not sure. That's our H, hours of overtime, and it's going to equal $588. So our equation is 40 hours at $12 an hour times $18 an hour for H, I don't know how many hours, and then his total is $588. So let's go ahead and multiply this through. 40 times 12 is going to be 480 plus 18h equals 588. So now it looks like we have a good two-step equation. We're going to subtract 480 from both sides first, and that will allow us to get this h business kind of by itself. 18h equals 108. And then we can divide both sides by 18, and h will be all by itself. We'll kind of move over here now. H equals, and 108 divided by 18 will be 6. So we're going to say he worked 6 hours of overtime. So put our unit on there. So it says Gerald worked 6 hours of overtime last week, and his pay was $588. Number 74 says, a person's weight on Neptune is roughly 1.2 times their weight on Earth. So however much you weigh on Earth, multiply that by 1.2, and that's what you're going to weigh on Neptune. So if Guadalupe weighs 115 pounds on Earth, how much does she weigh on Neptune? And let's get rid of that T right there. That says weight. So how much does she weigh on Neptune? Well, okay, so we're going to use W for weight on Neptune. And that's what we're going to solve for here. So W is what we want to find. So we know that the weight on Neptune is going to be 1.2 times the weight on Earth. So we can kind of put an E for Earth. We could also define that if we wanted to. E equals weight on Earth. Okay, so we've got our equation here. So we know that Guadalupe weighs 115 pounds on Earth. So 1.2 times 115 pounds on Earth. Now it really just looks like we're going to multiply this. So it looks like an expression, 1.2 times the weight on Earth. It's going to give us this weight on Neptune. And 1.2 times 115 is going to be 138 pounds. So we can say the weight on Neptune will be 138 pounds. There we go. That's the answer for number 74. Number 75 says, a certain cell phone company charges $32 for service each month and 8 cents per text. So if Jessica's bill was $184 for the last 3 months, how many texts did she send? So over the last 3 months, we're looking for how many texts she sent. So T will be number of texts. And that's what we're searching for. So now, what kind of an equation can we write? Well, it's $32 for each month of service. So we're going to say $32 times, and how many months are we talking about? We're talking about 3 months. And plus, since this 32 is in dollars, and this text business is in cents, we need to change this to dollars. So it'll be 0.08 times T, so the number of texts, and that's going to give us $184 total for all 3 months. So this was $32 per month for 3 months, 8 cents a text for how many texts? I don't know, that's what we're looking for. And when you add those up to make the total bill, it's $184. Let's go ahead and multiply this through, and you get 96 plus 0.08t equals 184. So it's a nice two-step equation. Let's go ahead and subtract 96 from both sides. And we get 0.08t equals 88, it looks like. And then we're going to divide by 0.08. So sometimes we have troubles dividing by these decimals, so here's what you can do. You can move this decimal over 2 places to make it just an 8, but then you also got to do it on the top, which will fill these in with zeros. So really what you're doing is t equals 8800 over 8, and if you do that division, the number of texts sent were 1100. So 1100 texts will be your answer for that guy right there. So again, we defined our variable. T is the number of texts. We wrote our equation. We solved our equation to get 1100, and then we made sense of our answer by saying 1100 texts, because that was what we were solving for, the number of texts. And number 76 says, Maria was at an internet cafe and she paid $5.40 for the time that she spent online. Now the cafe charges 12 cents for each minute that people spend online, so how many minutes did Maria spend surfing the internet? So we can set up an equation here, but first we're going to define our variable. So how many minutes, that's what we're looking for. So M equals number of minutes, because we're looking for the number of minutes that Maria spent online at the cafe. Okay, so it's 12 cents for each minute online. We're going to make these cents into a dollar, so 0.12 times the number of minutes will give us a total of 5.40. So 12 cents per minute times the number of minutes equals the total bill, which was $5.40. So it looks like just a simple one-step equation. We can divide both sides by 0.12, and those will cancel, and your value of M should be 5.4 divided by 0.12. But like we did in the last example, we can move these decimal places. Let's move it over twice, so it'll be 540 divided by 12. So when you take 540 divided by 12, you're going to get 45. And what does this 45 mean? We'll go back to M. It's the number of minutes. So we can say 45 minutes that Maria spent online at the internet cafe. So there's the answer for number 76. Let's look at number 77. It says Diego is saving money to buy a guitar that cost $860. He has saved $140 so far, and each week he adds $40 to his savings. So how many weeks will it take him to reach his $860? So the question is how many weeks? So we can say W equals the number of weeks. Okay, so now that we know W is our variable, how can we set up our equation? Well, we know that the total of the guitar is $860. So whatever I do, I'm going to put equals 860 because that's our total bill. I know that he has saved 140 so far, so I'm going to put this 140 over here, plus some business, hopefully, that he's saving each week, and it looks like he's saving $40 each week. So $40 each week times the number of weeks should give us the total of $860 when you add it to 140. So it looks like another nice two-step equation. So let's subtract 140 from both sides. And when I do that, those cancel out, and I have 40W equals 720. And I can divide both sides by 40. The 40s cancel over there on the left, and I get W by itself. And it looks like W is going to equal 18. So what does this W represent? Number of weeks. So my total is 18 weeks whenever I put my unit with it. So in 18 weeks, Diego will have enough to buy his guitar. Number 78 is a little bit longer of a problem. We're going to have parts A, B, and C. They're going to be asking different questions about the scenario that we're given. So number 78 says, 2 car rental companies charge different amounts to rent out their vehicles. So the first, company A, charges $30 per day plus 20 cents per mile. Company B is $50 per day and 10 cents a mile. So you'll notice company A charges much less for their flat fee, but then much, much more per mile, where company B charges more for their flat fee, but much less per mile. So if you were going to drive 80 miles, which company should you choose? Well, let's do company A, and let's do company B, and let's see. Company A is $30 per day plus 20 cents per mile, and it says 80 miles. So it should be 30 plus, and 2 and 8 is 16. So it looks like it's going to be $46 for the day. Well, we already know company A is better because their total is 46, and company B's flat fee is 50. We'll go ahead and charge it though, and we'll see what we'll work it out, see what it's going to be. So 10 cents times 80 minutes is going to be 50 plus 8 will give us $58. So which company would you like to go with for 80 miles? Well, definitely company A. So we'll say company A. Part B, let me slide down here, says if I was driving 315 miles, which company should I choose? Okay, well again, let's set up company A, company B. Company A is $30 plus 20 cents at 315 miles. And company B is $50 plus 10 cents for 315 miles. When I work this out, this will be 30 plus, let's see, this is going to be, what, $63 right there. And so when I do that, I'll get $93 total. And here will be 50 plus, it looks like maybe 31.50, should be 81.50 total. So which one is cheaper? Well, in this case, it looks like company B. So So in the first instance, we were only driving 80 miles, and company A was better. In the second instance, we were driving 315 miles, and company B was better. So we see that not necessarily one company is always better than another. So let's kind of see how many miles would you have to drive for the cost to be the same. So at some point, they're going to be the same. So if you work it out, we had M equals the number of miles, and that's what we're looking for. How many miles will we have to drive for them to be the same? Okay, so it looks like it's going to be 30 plus 20 cents per mile equals 50 plus 10 cents per mile. So now we've got a multi-step equation here that we can easily solve. Let's put our m's, or the variables, on the left side. So I'm going to subtract 0.10 m from both sides. When I do that, those will cancel, and I'm left with 0.10 m over here. I also have my 30 plus and my 50 over there. So now let's just subtract 30 from both sides. Those cancel. I'm left with 0.10 m equals 20. And then when I divide both sides by 0.10, 20 divided by 0.1 is going to be 200, and that equals m. And what does my m represent? Well, it's the number of miles. So at 200 miles, the companies will charge the same amount. So let's kind of talk about this a little bit. If at 200 miles they cost the same, we know from part A that anything less than 200 miles, company A will be better. Anything more than 200 miles, company B will be better. And at 200 miles, they're the same. So there's your solution for number 78. Number 79 is a longer problem, just like 78. And it says Jessica has to decide between two different companies in order to get her photos developed. So she's got two choices. Pics of you, and they just cost 38 cents per print. While development costs $3.91 for a flat fee, but then much less of 15 cents per print. So if Jessica has only 10 prints, part A, which company is cheaper? And then by how much? So the pics of you will be just 38 cents times 10 prints. So that's just going to be $3.80. Whereas the other one will be $3.91 plus 15 cents for each print. So $3.91 plus $1.50, and that's going to give us $5.41. So one's larger than the other. So which company is cheaper? Well, it's this guy. It's Pics of You, and that's going to be the cheaper one. But by how much? And let's go ahead and work that math. 541 minus 380 is going to be 1. Come over there and carry 1. Looks like $1.61 cheaper for Pics of You. Okay, part B says, now Jessica has 35 prints, so this time she has more prints. Which company is cheaper? And then by how much? So the Pics of You is 38 cents times 35 prints, and 38 cents times 35 prints will be $13.30 when I do that multiplication, where development was $3.91 plus 15 cents per print, and we had 35 prints, so it looks like it's $3.91 plus $5.25, and that'll give us a total of $9.16. So we've got two totals here. It looks like definitely development is cheaper though, because it's only $9.16, but cheaper by how much? Let's go ahead and do that math. $13.30 minus $9.16. 30 minus 16 will be 14 cents, and 13 minus 9 will be 4. So it's $4.14 cheaper. So that's part B. So notice again, in the first part, we only were printing 10 prints, and Pics of You was cheaper by $1.61. Part B, we had 35 prints, but development was cheaper at $4.14. So it depends on how many prints you're doing as to which company you should go to. And part C says, now how many prints would she have if the cost of the two developers were the same? So at what point, or what is that boundary where Pics of You goes from being cheaper to development goes to being cheaper, and at what point are they the same cost? So we know that the one company is 38 cents per print, where we're going to say P. So let's put up here, P is number of prints, and that'll be our variable definition. So 0.38 times the number of prints equals our $3.91 plus 15 cents per print. So now we've got a nice two-step equation. I'm going to subtract 0.15p from both sides in order to get those p's together. So we have 0.23p equals 391. And then when we divide both sides by 0.23, we're going to get p equals 17. So what is p? P is the number of prints. So it's 17 prints. What does that mean? It means if you purchase 17 prints or have 17 prints developed, the cost will be the same at each place. So that's kind of our boundary, where anything less than 17, our picks of you would be cheaper. Anything more than 17, our development would be cheaper. But right at 17 prints, they're going to be the same amount of money. So that's the answer to number 79. And our final word problem, number 80, says the sum of the interior angles of a triangle is 180 degrees. So that just means all the inside angles, when you add them up, makes 180 degrees. So in triangle ABC, the measure of angle A is 55 degrees, the measure of angle B is 6x degrees, and the measure of angle C is 4x plus 5 degrees. So we're going to find the value of x. Well, if I know I have triangle ABC and I have measures for angle A, B, and C, which are the three vertices or the three angles in the triangle, I know I can add up these three quantities and I should get 180. So I'll take 55 degrees, which was A, 6x degrees, which was B, and 4x plus 5, which was C. I'm going to add them all up and it should make 180. So at this point I need to combine like terms, so I have some constants and some x's, so 6x and 4x will make 10x, 55 and 5 will make 60, and that makes 180. So now let's subtract 60 from both sides. So 10x equals 120, and when I divide both sides by 10, my x equals 12. So the value of x equals 12 in this case. And part B says, find the measure of each angle. Well, we already knew the measure of angle A was 55 degrees. That was given to us. So the measure of angle B is going to be 6x, which is 6 times 12, which will be 72 degrees. And the measure of angle C, which is 4x plus 5 degrees, will be 4 times 12 plus 5. So it'll be 48 plus 5, so it'll be 53 degrees. So we have measure of angle A is 55 degrees, measure of angle B is 72 degrees, and the measure of angle C is 53 degrees. So this concludes our 10 word problems on our chapter review.